Hello everyone, this is Richard. Today I'm going to show you how to make animation using UNet model. Particularly, we are going to use Stable Diffusion and Dreambooth. Just for clarification, in this video, I'm not going to focus on all the teeny-gritty details such as installing VS Code or how to run Python files. Instead, I'm going to focusing on the entire process of animation in a very general sense. First, for additional information, please check out the Stable Diffusion tutorial on corridordigital.com. That tutorial is amazing. Second, if you are interested in how the UNet models work behind the scene for Stable Diffusion, you can check out this video as it explains the concept clearly. Lastly, if you're confused about what is the difference between Dreambooth and other UNet model training methods, I highly recommend you to check out this video as it is very informative. Then let's make our animation. When I said to make animation, what I mean is to film a video of an object with clear background, and then use our customized UNet model in Stable Diffusion to convert that video into animation. In order to do that, there are three things we have to collect. The first thing you need is a UNet model checkpoint. You can find such a checkpoint in Hugging Face. People commonly use the Stable Diffusion 1.5, and as you can see, there are a bunch of this type of model here. Another way of find a model you want could be to go to the Civit AI. There are a bunch of fan-made model checkpoint here, and let's say how if I choose this model, then basically I will search up this model in Hugging Face and pick one version of it. So let's say how if I pick this one, then basically what I will do is that I will right click on this and click on copy link. In the next step, we will go to this fast stable diffusion GitHub repo made by the last band. If you scroll it down, you will see how there are two ways that we can do Dreambooth. The first one is that we can do Dreambooth on Colab. The second way is that we can do Dreambooth on the server that provide great GPU. For our case, we can just choose the first way, which is to do the Dreambooth on Colab. If we click on the image, we'll jump to this Colab, and basically what you want to do is that you want to copy this Colab to your own drive. As you click on this one, you will save a copy of the Colab. Then basically what you want to do is that you want to just run those code blocks one by one. For the first one, you'll just say you're not a robot and verify that. Then basically when this question pops up, click on connect to Google Drive, and then pick your drive and allow it. And we can just wait for this chunk of the code to run to the end. Okay, you can see when we can see this green mark, it means how this chunk of code has been finished. Then we can start to run the next chunk of code. After running this, in the end, it will show this comment, which means how this has been successfully run through. In the model download, you will paste the link you copied previously. And if you just straight away run this code, you'll get this error message saying how it's a wrong link. Initially, I also ran into this problem, and what I did is that I went to the Discord of this author and asked a question to her. And basically, what the author said is that we should change this blob to resolve. Yes, and then it should fix the problem. If we run it, and also there is a side story, which is how after I fix this link, actually when I put it here and when I click run, it still give me an error saying how there are some conversion problem, and I don't know how to figure it out. So basically, I just contact the last band, which is the author of this collab, and the last band is really nice, and he basically fixed the bug, and now everyone can run this. Yeah, so you can see how the model is being imported from the Hugging Face to this program. So just to emphasize, whenever you want to pull up a model from Hugging Face to here, be sure to change the blob to resolve. And as you can see how this chunk of code has been finished. So basically we get the first thing we need, which is a UNet model checkpoint, and we load in this model checkpoint to the program. Okay, so the second thing we need is a bunch of image of the object you want to animate it in different angles. And also the background of the object should be very clear. So let's say how if I want to animate myself, then I will collect a bunch of image of me with clear background. As you can see how they all have a green background. Then the third thing you need to collect is a bunch of images in the style that you want to animate it. So for me, I collected some images from Genshin Impact characters. After this step, basically what you need to do is that you want to resize both of the images, both folders of the images into 512 by 512. And basically the way I did that is that I create a very simple code, and this code will basically loading the image I want to resize of, and then you will output me with the new images of the right size. So after this, basically I will get a bunch of images that are in the dimension 512 by 512. As you can see how here, they're all 512 by 512. And same thing goes for the style images. They're all like 512 by 512. Then we need to go back to our Colab. So the next step, basically, we need to train the idea of the object. In this case, the object is me. We want to train the idea of the object into the model we loaded, the model checkpoint we loaded. And the way we do that is that first we rename all the images of the object to like a token, and then it's the index of the image, just as how it's being specified here. After that, we will put the prefix, which is a token, to this box. And then we click on run. Okay, and then we go to the next box. Here, basically, you just click on run. And then you are asked you to select the files. So basically, it's asking for you to load in the image of the files in this case. So I will just click on choose file, and I will direct to the folder of the file here, and I will just click on open. I will first select all the images here, and then I'll click on open. And you see how all the images has been loaded here. Okay, nice. So for the next step, we need to run this chunk of code. And then we have to select every image we loaded and put a description of this image. As you can see how I suggest that this image is related to this token. And also I added some additional details about this image. And I click on save. I go to the next image, and I will do the same thing. Same for the third one, and same for all of the images. After we put labels to all of the images, then we can go to the next step, which is actually not the regularization. Basically, I tried this step by myself, and I didn't observe significant improvement of the quality of the images generated with or without this step. So generally, I will just skip this step. Then we can move on to training. Typically, I will first train the model by 600 to 800 training steps. For the other values of parameters, we can just keep them as a default value. And then we can just run this code. As you can see, now the program is running, and the program is training the text encoder of the UNet model, and also I assume some layers inside the model. Based on my own experience, this process could run for around 20 minutes. So in the meantime, we can do something else and wait for the model to finish. So after you train the model, you will see this comment saying how the model has been put into your drive. So if you go back to your drive, you'll see there's a folder under the name of Fast Dreambooth. If you if you click on that, direct to the session, and you will see a folder that is under the same name as the name of your token. If you click on this, you will see how we have a model saved here, and the model and this model is one that we retrained based on the image of objects. Next, following the same procedure, we also can train the concept of the style of animation we want into the model. So basically, we can just rerun all the codes from start to finished, and noticeably, on step 3, we can just direct this download code to the model we just created, which is in the drive under the Fast Dreambooth and here. So basically, we can just right click on this and copy the path and paste it here. We can get rid of this and unclick the Shift tensor and run this chunk of code. The following steps are very similar. Basically, we just need to create another token corresponding to the style of animation we want. And basically, we just retrain the model so that we add in the concept of the style. After the second time of retraining, we will end up with a model that knows both the concept of me and the concept of the animation style we want. Next, to use this model, we can download the Stable Diffusion locally by using this repository. In this repository, we can just scroll down to the part about installation. And here, we will first install some needed packages, and then to install the code itself for Stable Diffusion, we can just scroll all the way back to the top and click on the code and download the zip file. Once you downloaded the Stable Diffusion, you can open the file. First thing, you need to open the models, go to the Stable Diffusion. In the initial setting, you will not have any of these models. So what you need to do is that you want to go back to your drive and download the model you just retrained, and then put this model into this folder named Stable Diffusion. After that, you can go back to the top directory and then scroll down to the web UI user here. Right click, click on the edit, and then be sure to put these two arguments in this line. And then you can save the changes and close this tab. And then you can double click this web UI user Then, after you wait for a moment, a tab will pops up showing you this type of UI, and you can select the model we just put into the folder here. And then we can type down some positive text and negative text. Here, we mentioned how we are going to uh, draw the image in the style of this token, of which we already trained the model based on. And also we mentioned the token which is corresponding to me. So I'm sending the message that I want the model to generate an image of me in the style of the style we trained the model on. So let's just try to click on generate. Yeah, and you see how the image has been generated. So basically, the next step you want to do is that you want to increase the batch size. Let's say we increase it to 6, and let's hit generate. By increasing this count, you are telling the program to generate images based on these prompts again and again. And you can see how the model is generating a bunch of images. The hands are still deformed. Yes, and you see how some of the uh, image generated are are like better than others. For example, I see how this one is very stylish, and I like this image. So what you want to do next is that you want to uh, basically keep running the program to generate a bunch of images, and then pick some of the best ones. For example, here are 22 well-generated images I downloaded, and you can see how they are very stylish, and also you can tell that they are me. So uh, yeah, they are very well generated. And basically, the next thing you can do is that you can retrain the style token using um, these images you generated. The process will be exactly the same, but this time you will decrease this value to 0, as you don't need to retrain the text encoder of the token for your style. Finally, after the third time of retraining, we get this model for the conversion to the animation. To use this, let's first pick a video. This is a very short video I filmed about myself, and to keep the task easier, I keep the background relatively consistent. The first step we need uh, to take is that we want to convert this video into all the video frames. To do so, I made a small Python file here, and basically when I run this file, it will output me with all the video footage, which is here. You can see how the video has been turned into a bunch of footages. Then let's go back to the Stable Diffusion and test out how well our model performs. We go to the image to image, where we can drop off some of the video frames we generated. And then let's change the setting. You can also play around with the settings and see what are the values that works best for your case. Okay. And then let's click on generate. And there you go. You can see how the model is able to capture the right angle, and it can generate me in a very stylish way. So the next procedure is that we will just feed in all the video frames we created into the model and let the model to convert every video frame to the animated version. To do so, we will hit the batch button, and then we will put in the directory of the folder that contains all the video frames we have. We'll put this directory into this box. And here, for the output directory, we will put the directory of the folder in which we want the generated video frames to be. And down below are the settings I used. And as we click on generate, the program will run. For me, when I tried to generate around 600 images, it takes me around 2 to 3 hours, just to give you the perspective of how long this process will take. After the process, you will end up with a sequence of animated video frame, and then you can use some small Python program to convert those video footages into an animation. To show you the end result, this is an animation I generated. As you can see, there are still a lot of flickerings going around, but I feel this is a great start point for anyone who want to use the Stable Diffusion in the production of animations. I hope, and you see the hands are still very could be very deformed. I hope you enjoy this video and found this video being helpful. And if you know how to reduce the flickerings, please let me know so that I can also improve my own animated videos. Thank you.